Greetings and welcome, friends. Today we are continuing our look at graphing absolute value graphs. And this is actually going to be a really interesting graph. Let's look at f of x here, folks. That will be our starter graph. And f of x, let's see what you can tell me about that. This plus 2 is the same as I'll label that as a horizontal shift. Right, horizontal shift, which direction? It's going to be left 2, all right? And that minus 3 is going to have done the another shift, except this one will be a vertical shift, down 3. All right, so we guys, we all know what our regular absolute value graph looks like. It's something like the prettier version of that. So instead of my vertex being here, my vertex is going to have been shifted left 2 and down 3. It's going to be right there. All right, and the slope of this has not changed. It's still a plain old absolute value graph. And let's see, we are so familiar with what that looks like. We know that it's going to go up 1 over 1, up 1 over 1, up 1 over 1, which is actually a 45-degree angle, as you saw there just a moment ago. And the slope on the left side of it is actually going to be a slope of -1. -1. All right, so here's the graph of f of x. F of x. All right. But now they ask me to graph g of x. Gee willikers. All right, and g of x actually has a few things happening to it. Well, actually, what's the difference between these two things? Yeah, the g just has this extra 2 here. Yeah, indeed. So the g has that extra 2 there, and that 2 is applying to the x in terms of sequence, like in terms of PEMDAS. That's applying to the x before it's being added by 2 or absolute valued or subtracted by 3. So g of x, we could actually, oh dear, what did I just do? Oh dear. I do not know. Hopefully I didn't undo anything that I... Control-Shift-Y. I just opened the dictionary. There we go. I don't know. So anyways, g of x, you could argue, is equal to, is the same as f of 2x. f of 2x. All right? Because if I took function f and replaced x with 2x, right? Wouldn't that be the same thing as that? You guys agree? And since it's f of 2x, that means compared to function f, it will be a horizontal, because the 2 is on the inside, shrink by 1/2 of f of 2x. So what I'm doing here in this problem is I'm pretending my parent function was f of x, this blue graph that I have here. And so if I want to do a horizontal shrink by 1/2, what I could do, notice this point here has an x coordinate of 2, and 1/2 of 2 is what? Is 1. Yep, so that got shrunken. Here's 4. 4 divided by 2 is 2. So that got shrunken horizontally. Here is 6. Why am I picking even numbers, do you think? Yeah, I want to divide by 2, and even numbers divide by 2 wonderfully. 6 divided by 2 is? Yeah, 3. So that's going to be there. Let's look at this one. What's 0 divided by 2? 0. Here's 2. 2 divided by 2 is going to be... Or actually, sorry, my bad. That was -2, and -2 divided by 2 is now at -1. Here is -4. What's -4 divided by 2? -2. And -6 divided by 2 is -3. So notice this new graph is a horizontal shrink of the other graph. What's weird is that its vertex actually changed location a little bit as well. Isn't that a little bit weird? I'm sorry, I couldn't hear the question. Oh, I was all excited about a question. All right, we'll never know. But yeah, so all of the x coordinates of the blue graph were halved, and it resulted in a graph that looked like that. All right, so there is a way to transform graphs that are not simply the original parent function of right, f of x equals the absolute value of x. All right, let's talk about vertex form today. This form is the coolest form. It's going to be so much better for graphing. Now, you guys remember that back in the day, when we would graph y equals mx plus b, we would start at the y-intercept, right? We'd start at the y-intercept, and then we'd move by our slope. It turns out a very easy way to graph absolute value functions is to start at the vertex, all right? And then move by your slopes, right? And so you'd have a plus or minus version of the slope. So when a is 1, the slopes are up 1 over 1, right? And up 1 backwards 1, up 1 backwards 1. And if I start at the vertex, I could actually land there quite well. Watch this. If I change the vertex, let's have it be at 2 and, I don't know, like -3 or something like that. That if I had the equation y equals the absolute value of x minus 2 and then minus 3 on the outside, I could start at my vertex 2 comma -3, and then I could just move by my slope up 1 over 1, up 1 over 1. And this is going to be a super fast way of graphing where we find the vertex and then we move by our slope. And watch, even if the slope was different, let's say the slope was 2, notice I would go up 2 over 1, up 2 over 1, up 2 over 1, as well as up 2 backwards 1. And that I could actually graph that pretty easily. And you can even have negative slopes, right? And you could see I could go down 3 over 1, down 3 over 1. And so if I start at my vertex, it will actually be so much easier to graph. All right, and I'll just move by my rise over my run is the plan. Let's see. So let me show you this little vertex form, friends. Let's see. Where am I? Here I am. All right. So vertex form of an absolute value function. All right. What we're gonna do is it's written in the form a times the absolute value of x minus h. All right. H is going to be important, and then plus k. And k is going to be important, where a is not 0, because if I just multiply by 0, it won't be a very interesting function. And it says the vertex is h comma k. So we're going to start at the vertex, and then I'll even go as far to say let's add this to yours as well, the slopes, I'm going to put that in quotes, are going to equal plus or minus a. Right? Yep. So this is in your packet. I think in yours I actually accidentally had this before example 3 instead of after it, so my apologies. So your slopes are plus or minus a, your vertex is there, and then you can also find the axis of symmetry is just going to be the line x equals h. And x equals h is the mirror line, if you want to think about it that way, is what that represents. So let's do example 4 together. Can I line this up? I think I can. I'm gonna try. It's gonna be amazing. Man, I don't know how I haven't been discovered on the internet for my amazing singing voice yet. I'm quite perplexed. So here we go. This is going to be so much easier to graph. All right, mathematicians, we are an efficiently lazy people, and that's the way we want to graph. So okay, so here's my equation. G of x equals -2 abs x minus 1 plus 3. What is the a value, which will then behave as my slopes? What's the value of a? The a is going to be the number in front of the absolute value. So the a is the -2. And absolute value makes negative numbers positive, but this negative number is on the outside of the absolute value. Yeah. Let's see, h. What's h going to be? Now, it's of the form x minus h, so it's actually going to be the opposite of -1. Yeah, so be careful of that. The h1 is tricky. And then what's k going to equal? Yeah, k is going to be the 3. All right? And so you could say that your vertex is 1, 3, if that helps. I'm going to have us label it as h and k as well as the vertex, at least for this example, but I won't need you to do both at other times. So let's plot the vertex first. We begin at the vertex. So 1, 3, Devin, I think, right? So over 1, up 3. There's my new vertex. And I'm going to move by my slopes. So my slopes are going to equal plus or minus the a value. Plus or minus 2, I'll call that. I guess I'd have to know that it's upside down as well, shouldn't I? Maybe I should call that minus plus. It doesn't matter. But yeah, I'm going to go down 2 and over 1, plot a point. From there, I could go down 2 and over 1, plot a point. Down 2 and over 1, plot a point. And I can also, starting from the vertex, go down 2 backwards 1 and plot a point. Down 2 backwards 1. And this is going to be so much easier to graph than thinking in terms of translations and transformations and stretches and smooshes. Oh dear, yeah. So my graph ends up just looking like this. I start at the vertex, just like we did with slope-intercept form. We started at the y-intercept in that case, and then I move by my slopes. All right, this is going to be super easy. You guys are going to be absolute value experts. I'm loving this. I'm loving this. But then they did say, describe the transformations from the graph of f of x to the graph of g. All right, so if this was done in terms of transformations, it would have been done the following. So yeah, the transformations would have been 1, starting on the inside, it would have shifted, horizontal shift. And we won't have to describe these all the time. I'm just mostly going to be interested in your graph. But horizontal shift, what was it? Left 1. Left 1. 2, the next thing that happens to x by order of operations would have been multiplying by -2. So it would have been a vertical stretch by 2. You could combine. You could say by -2, and that's fine. If you wanted to make a reflection as another step, you could have. And then step 3 would have been the last thing that happened to my x, which is a vertical shift by up 3. Yeah, by 3. Right? And so notice that actually is how I could have gotten this, but I think it's so much easier thinking about this in terms of, right, let's see, what was the value of a? The value of a was -2 for us. And it was 1, 3. So h was equal to 1. And k was equal to 3. Was it positive 3? Yeah. Right? And I think this is way easier to think about just, right? than having to do the transformation stuff. So yeah, start at your vertex, down 2 over 1, down 2 over 1. Move by your slope, and it's going to be el más fácil del mundo. So let's, I've got another problem that I think I'm calling example 4.5 on your guys' packet. Yeah? Yeah, we'll do that one. This was one of the ones that I made up myself. Because I'm so creative. It's amazing. Alright, so. And then this is good. We're actually going to have time. Even though it's a half day, we will have time to do some class questing. I don't know. Because we already did example 4. And this was after example 4. So I figured it was a good number. Yeah, I can answer that question later if you'd like. Let's see, the value of A is the 1/3. Could someone tell me the value of H? -1, the opposite. And the value of K is -3. All right, so my vertex is at -1, -3. Watch how quick we can graph this. Go to -1, -3. So left 1, down 3. There's my vertex. And the slopes are the A thing, right? So that's going to be up 1 over 3. And then I'll also have up 1 backwards 3 as an alternative one. So from the vertex, move by my slope, up 1 and over 3. And get a couple other points, up 1 over 3. Up 1 and over 3. And then I can either mirror that over the axis of symmetry, or I could go up 1, backwards 3 as well, right? Up 1, backwards 3. Up 1, backwards 3. And I can end up graphing my parabola. Nope, I lied. I'm super lying to you. Parabolas will be graphing in a later chapter, although they behave very similarly. Yeah, this is an absolute value graph. It's my V graph. There we are. So there is your graph. And also, we didn't do it for the last problem, but the axis of symmetry, they told us was going to be the equation x equals h. What was h for us? Yeah, -1. And the equation x equals -1 would represent a vertical line that passes through -1 on the x-axis. So this isn't a part of my graph. It's just like this is like your mirror line where this side over here gets reflected over there. All right. So let's yeah, I think we'll call it there. I think that'll be enough examples for you guys to work with. Thanks for watching, internet friends. Bye-bye.